Okay, so here we're going to prove this set equivalence, and I'm going to show this here. And what we want to do is show that for any element in the left-hand side, it's in the right-hand side, and for any element in the right-hand side, it's going to be in the left-hand side. Now, the first thing we want to just know that when it writes this union k1 to n of ak, we want to get a definition of what this looks like. This looks like just A1 union A2 union A3, and there's just n sets here. You go down, okay? That's what this means, right? Just get a definition. So then similarly, like over here, right, on this right-hand side, we should see this as, if I write out the right-hand side set in full, B intersect AK. Right, what does that look like? It looks like B intersect A1 union B intersect A2. And again, dot, 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 union, dot, 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 union B intersect A sub K. And, that's just going to help us kind of have an idea of what these unions and these indexed unions look like. Okay, so now let's start. So let X be in the left set, and I want to show that it's going to be in the right set. Okay, so if X is in this set, then that means that X is in B, and right, X is in this union. Okay, now if X is in this union, then there must exist. So let's just make a side argument here. Let's just say, right, since X is in this union, right, there must be at least one set in the union say A sub I with X contained in A sub I. Okay, so that means that X is going to be in B, and X is contained in A sub I, at least some A sub I, okay? Now, if X is contained in B and X is contained in A sub I, X is in the intersection between these two. But, okay, if X is in the intersection of these two, then that means that X is in the union of all of them, right? Because this is some A sub I in this here, right? So, right, if we're looking on this right here, right, if we're looking over here, let's say, right, if we're looking over here, right, we see that B intersect A sub I will be one of these, and X will be in here. So then X is in this whole thing because this is all unions. So it's or. It's everything together. So then that means that X is contained in the union. K goes from 1 to N of B intersect A sub K. And that's one direction. I showed that if it's in here, then it's in here. Now I need to go in the other direction. So I need to say let X be contained in this union. Right. Then that means that X is contained in B intersect A sub I for at least one again, for at least some A sub I in that union. And then if X is contained in there, then X is contained in B, and X is contained in A sub I. Okay. Now, if it's the case that X is contained in B and X is contained, okay, so there we go, that's what I needed, I see. So if X is contained in A sub I, then this one implies, right, so I was looking and I was like, wait a minute, what's going on here? And I see this over here, right, and I was like, this is key, because X must be contained in some A sub I, so X is contained inside the union. Right? And then that means that I have X is in B and X is contained inside that union. Not I, K. Because, this again, if you look here, right, A sub I is one of these going down, right? So if X is in A sub I, then it's in this union because A sub I is one of the things in that union. And then that means that we have that X is in B and X is in this union, so we have the other direction. We have that X is contained in B intersect the union. And then we're done because we did it in both directions.